show. Here we have our presentation on wind turbine technology. It's Mr. Merle's classroom, Eric Jaramello, Ben Roque, and Ben Frumkin.
This is our team tagline, energy transcending into the future. We all think it's pretty clever.
Yeah.
So our idea is, on electric cars, one of the main problems is that they have limited range because of the limited battery life. So a way to extend the battery life might be to attach a recharging system so that the car could recharge as it drove. So we decided to use wind turbines to power the car. So we're going to put holes through the chassis of the car with little turbines inside them, so as the car goes, the wind will, instead of going over and around the car, it'll want to go through the holes because there will be less resistance, and that will turn the turbines at high speed, generating electricity for the car.
That sounds like a good, sounds like you've got a very good direction that you want to go to.
Thank you.
Okay.
Well, here we have a rough sketch that we first made when we thought of this idea.
Use the markers and go ahead and detail the drawing.
So you'll notice that over here it has a little water-powered turbine. So that was our original idea, and we changed it to wind power later. But here's like how the electronics of an electric car work. You have the potentiometer attached to the gas pedal, which is then attached to the controller, which has batteries and the charger. So we were going to link up some generators to either the controller or the battery array, which would be powered by wind.
Okay.
Oh, wait. Oh, wait.
Here's a model that Ben made for us in Vex. We got the car inventor. Sorry.
Yeah, I was gonna say, it takes a lot of C++ programming for that.
So
Go ahead, Erwin.
here's the electric car that he made, and it's gonna have 2 holes in the front. That's gonna illustrate for you guys.
Now
And that's where the wind's gonna flow into. Then later on, we're gonna show you the wind turbine that.
again, it's just a rough sketch. It's nothing. We're not gonna have
Is
to color
there,
anything like that.
is there a reason why it's got such a tall,
No, well,
No. This is just a car that,
Yes.
oh, okay.
that we created.
It's just a car design. One reason why it would have a tall thing is because it's very hard to get miniaturized turbines, so you might need to make extra space underneath to fit in the turbine.
which would increase the cost of the car?
Yeah. The smallest turbine we've found so far is about 1 foot by 1 foot. So that's
The
a
good,
serious
the
concern.
good news is that the design that you have screens unibody construction, which is the idea behind Volvos and Saabs. The reason why Volvos and Saabs are considered very safe cars is that the top part of the car, everything but the chassis, right?
Right.
Is supposedly one big piece, kind of like that, you see? Instead of like a bunch of different pieces, like Chevys or Fords, the way
Right.
they build it. The unibody construction allows for the distribution of forces, so that when you're, God forbid, you're in a car accident, forces are distributed a little more evenly. But we can talk about that another time.
Closing later.
So inside the holes would be a miniaturized turbine.
And
as small
that
as
of course
and
is
a
the
generator.
generator, okay.
Um,
Now how big is that generator?
Well, we're still trying to work out exact sizes,
See which
but
is more efficient.
we're hoping we can find one that's at least as small as the turbine, if
Okay.
not smaller.
So here's one of the types of turbines that we're going to use. It looks pretty big in the picture actually, but it's really only just a foot by a foot. And this is just one of the ideas of the turbine that we're going to use in the car.
The thing about this turbine is that it was homemade, so if we got one that was like professionally manufactured, it could probably be made even smaller.
Sure.
So that's something to work on.
Yeah, I'm sure they have smaller wind turbines, but they're probably not made much because wind turbines usually have to be big to produce energy. But since it's for a car, they can probably manufacture one that would work out.
Okay.
And problem to solve.
Roby, why don't you take that?
Alright, so this innovation solves two different problems. It allows an electric car to travel for a longer period of time before it needs to be charged again. So like while the car is running, the wind turbines, obviously when the wind goes through the holes, it's going to be charging the battery of the car, making sure that you don't need to put as much time into charging the car once you get home. And then also it ends up with more power at the end of the day.
Makes you wonder why hybrid cars like the Leaf or the Volt don't have this
Yeah.
already.
That's
Right, yeah. That's what we were thinking. That was it.
this is why it's innovative. Well, it's innovative because basically there's nothing like it already made. It enhances the life of the battery due to the wind turbines. It generates energy from the kinetic energy from the winds. Hopefully it'll be very effective, and it's another way to decrease the reliance on fossil fuels like gasoline and all of these other things and start using electricity.
Most of my friends are at that age where they're seriously thinking about the environment and about the future with their children and all that. And most of them have decided to go with a hybrid or an electric car. My friend in California just bought a hybrid. My other friend who lives in Celebration, the subdivision that Walt Disney built for people that live in Orlando, since he teaches at the high school, the Disney high school, Disney has a deal with any teacher. You hand in your car and they will help subsidize the hybrid for you. So he handed in his car, he got a Prius. And then my other friend who works here as a database programmer, he is on the waiting list to get a Volt. And of course, John Gratulis has a smart car. Other kids here have seen smart cars. Yeah. Okay.
What you to explain. Alright, so this is the only like invisible car we could find explain.
Transparent car.
Yeah, transparent car. Basically, the turbines there's gonna be a few holes here, maybe 2 or 3, just depending on how much you're more efficient. And we're gonna have turbines here. Sorry, not the most artistic. Turbines here, and then there'll be the generator. Well, the engine isn't obviously gonna be back here.
Right.
It's gonna be it's gonna be here. But the generator is attached to the engine, or not to the engine, to the battery of the car. And while this spins, it's going to spin the shaft that spins the generator, which makes electricity and then charges the battery.
Well, actually, one thing about electric cars, it doesn't exactly have an engine. What it has is little motors attached to each wheel, which then take power from the battery. And so what it would have up here would probably be the controller and the array that we had a little concept sketch of earlier.
Got the key products here. Key product features are the wind turbines, the electric generator that we want to get for this electric car, and the vents in the car chassis that allow the air to pass through freely. We're gonna have to make holes in the car, which are gonna allow wind to funnel into.
Additionally, we might put in a way so that you could close the holes up if you wanted to stop it from running. the charger.
Why would you wanna stop it from
Well,
working?
say you were going in reverse, it might actually cause more problems in air resistance.
Maybe when you go in reverse, it'll close the holes automatically.
Oh, okay.
Oh, that makes sense.
Alright, sure.
And that's it.
That's our presentation.
I have a question.
Okay,
Any questions?
question?
How much power are you gonna get out of a spinning fan to charge up your car battery? Because that's a lot of charge that you need. I mean,
It's not,
a little
it's,
fan
thing
be
is
able
it's
to
not,
do that?
it's not powering the car, it's just charging it.
Yeah,
It's not
charging
gonna-
it, but still, I mean,
Well,
I have like an innovation for you guys, like a better idea.
well, we haven't actually worked out the calculations yet, but
We
for
tried this
a
today.
foot by foot, we should be able to get a fair amount of energy per month at least. We haven't worked out daily calculations yet,
What's your innovation?
but we
Use the power from spinning wheels to get electricity instead of the fan, because you're gonna get a lot more rotations out of that, a lot more RPM.
that's not really going to work because the fact is we're using power to turn the wheels, so we can't really get power from turning the wheels.
Well,
You can.
aren't you using power to get wind to go into the car? Because at stationary state, there's no wind going into the car. However, when you're using energy from the wheels, there's wind going into the car.
I mean,
So couldn't you argue that the same energy that he wants you to use is the same energy that you're going to want him to use? However, he's using it at an earlier state, so it's going to be more advantageous to use.
and you're not giving power to your front wheels either. I mean, there's nothing there. It's easy to attach something.
We are giving power to the front wheels. The way an electric car works is there's a little motor attached to each and every wheel.
There wasn't in that diagram.
Yeah, but that was not
That was
an
a
electric
false
car.
interpretation. That was
The
from the
problem
internet.
was we couldn't find a diagram of an electric car that had
It's
the
transparent.
transparent.
view.
Okay, excellent points from both the audience and the presenters. Excellent points. Okay, next.
I saw when you made your turbine, aren't there better turbines for your purpose? Like the classic like fan type turbine isn't as good as the like the double rollover turbine. Understand what I'm saying? Like have you thought about what kind of turbine you might use because maybe it's more
There might be some that are more efficient, but for now we.
No.
What our goal is to maximize the amount of wind we can get in as small a space as we can get.
okay.
So,
Any other questions?
Yeah, I just
comments?
got it from the person. Think of a good question. I'm interested in it.
I mean, it is a very intriguing idea. I wonder why this has not been implemented yet. I mean, not necessarily the fans, but some way of trying to capture the energy that is lost when an electric vehicle is moving. Just trying to somehow capture that momentum. Remember, momentum is energy, right?
Yeah.
Somehow trying to capture that momentum and store it
They
into
do.
electrical energy.
They do have ways. When you're not actually pushing on the gas in the electric car, it's always generating electricity because when the wheels are moving, they're connected to an axle, which is in the actual. Because you know a motor works both ways. You can put energy through a motor and it'll cause the axle to spin. Or if an axle spins, it'll cause electricity to come back to the motor. So what they do is once you're done moving, your wheels are still spinning or your axle is still spinning. So the energy goes back into the motor, or the kinetic energy is going back into the motor and you're regenerating the electricity.
How are you gonna harvest this power? Like, there's a spinning fan, but what is it connected to? How is it gonna take
well,
it from there to there? What's converting it to electricity?
we're going to have a little electric generator attached, which will be plugged into the battery.
Have you decided whether you're going to use an AC or a DC generator?
Well, that's something to think about. We haven't had time to look into the advantages or disadvantages of each, but that's definitely.
If it's energy that's going to be stored to work with the batteries, then it would be DC, obviously. But if it's energy that's going to be used to power an electronic device in the car, then it would have to be AC. Now, it's real easy to convert DC to AC with an inverter. So AC or DC is really, at this point, is immaterial. Yes.
Have you thought about just like, what about electricity from the car itself, like the radio and lights, air conditioner? Is that gonna affect that too? Will it help that also, or will it just be the
Well,
engine?
As I
That's
understand
even
it,
covered.
I think all of those things are plugged into the battery as well of the car, so this will help with those. Because since it's just putting the electricity into the battery, it can be used for anything that's plugged into the
How
battery.
many batteries are in your car?
Well, the way an electric car works, well, at least the ones that we found, they have like an array of like 1,000 laptop batteries in the back of the car, and so basically we're just going to be charging those up as the car drives.
Okay, Alt P, very good presentation, guys.